Welcome to Data Skeptic, a podcast exploring the methods, use cases, and consequences of recommender systems. Welcome to another installment of Data Skeptic Recommender System. In this episode, we're putting the spotlight on a somewhat new Python library called DataRec. It aims to provide a standard tool sets for reproducible analysis. I've been covering reproducibility on the show since probably just about the very beginning. And DataRec takes those values and brings them specifically to the recommender system world. It'll help you with dataset management, versioning, and making everything a lot more traceable. So if, for example, you're working on a new approach, a new methodology, and you want a benchmark, I know of no other better tool to get standardized datasets to try your methodology in a variety of contexts. Maybe you've got your own data, but you want to split it and clean it and things like that in a nice way. That's yet one more of the features DataRec has available for you. Maybe you want to head over to their GitHub page while you hear the interview. Either way, let's jump right into that.
I am Alberto Carlo Maria Mancino from the Sysintflow Laboratory at the Politecnico di Bari in the south of Italy. And basically, I'm a postdoc researcher that devoted his whole research career on recommender systems. So happy to be here talking about the recommender systems.
So where does that story begin for you? Is it as an undergrad or something else?
Yeah, it started with my master thesis. So I started studying recommender system with my master thesis here at the Sysintflow Laboratory, and now we do recommender systems since a while. So I found this very nice environment to learn, to study recommender systems. So I started with that, and I'm still continuing on.
And so that's been a good amount of time to see the field, and I guess a lot has evolved in that time as well. How have you seen the field change?
You know, we have to mention LLMs if we want to talk about evolutions in the recommender systems research. And before LLMs, we had a lot of novelties because in recommender systems, you can basically apply all the novelties that comes from machine learning research. So if there are new architectures, new way for feature extraction, and so on, you can always find a way to develop them in recommender systems and exploit them to make them even greater. At some point in the previous years, we had like a situation where we didn't have so many new technologies, so many new architectures that changed everything. We were, just improving the already existing methods. But with LLMs, we had a new paradigm. So nowadays, if you take a look at conferences on recommended systems, you will find a lot of papers on LLMs. Not all of them about use LLMs or generative models, but you can find a lot of them.
And could you say a few things about your specific areas of interest? Recommender systems is a pretty big topic. Where have you specialized or contributed yourself?
I started with knowledge-aware recommender systems. So recommender systems where you use knowledge graphs, so public knowledge graphs, but you can also use private ones to improve the recommendation performance or to induce some specific knowledge. Then I moved to graph-based recommenders because graph-based recommenders can easily be merged with knowledge graphs. So it's even more easier to exploit them. And I also saw that in Data Skeptic, you did a season on graphs and GNNs. It was very interesting because I think that with graphs, you can do a lot of things. They are very, very easy to manipulate and to do very, very cool stuff on them. And recently, I moved on analyzing some specific aspects of recommender system. For example, we published a paper on the importance of privacy in recommender systems because, you have to deal with user data. So you need to be aware of the importance of protecting user privacy. And also very recently at Rexis, which is, let's say, the main conference on recommender systems, we published a paper on the importance of novelty in the recommendations. It means that you do not focus only on the accuracy of your recommendations, how good they are, but also how much diverse they are, because you want to give to the user a very nice experience. So you don't want the user to consume the same kind of items every time, but to let the user explore the overall catalog. So as you said, in recommender systems, you can do a lot of different things. So it's also easy to being attracted from all different kind of novelties and interesting aspects. So yeah, I did very different topics in recommended system, but they all are very cool to study.
So you covered a lot of ground then, methodologically speaking. Along the way, what sort of data sets can you rely on to do that work?
Basically, in research, what you can do is to do the so-called offline evaluation. It means that you don't properly have a platform where you can test your recommended system. Of course, if you are in the industry and specifically in a company that deploys recommended systems, you can do that. You can do, for example, A/B testing and so on. But if you are not in a company like that, if you are in a university, you have to find a way to test your algorithms. And basically, you do that with offline evaluation. It means that you have data sets that are already prepared and shared, publicly shared. And on those data sets, you do all or your tests or your evaluations, you compare models, strategies. And as I said, I analyze different aspects of recommender systems. I had to deal with different data sets, with different ways for managing these data sets. So if you deal with recommender systems in research, and in particular with offline evaluation, you will see at some point that there are flaws in this process because data sets usually are copy and paste, or authors do not refer always to the right source uh, for retrieving these data sets basically. And what happens is that even a smaller modification in the input can have a large impact on the output, and this can affect the performance of recommended systems and basically the comparison of the performance of different models, which is the main way we use in the research to understand if a specific approach is good or not.
So I hear the famous movie lens dataset come up quite a bit. Are there any other canonical ones that you found to be particularly popular as you did a literature search?
Yeah, there is, for example, Last.fm. It's a dataset for music recommendation, but also there is a collection of datasets retrieved from the Amazon platform. So you have a lot of datasets extracted from the Amazon platform. So by taking the reviews of the users, so you have the stars, you also have the comments. So you can also do a review based recommendation, which means that you process the review to find a strategy that can lead you to recommend good items for the user based on his or her reviews. So you have them. You have Gowalla, which is another data that is a point of interest data set. You have a lot of them. There are a lot of data sets that you can use. Sometimes it's also difficult to compare results within different papers because one paper used one kind of data sets, another one used different kind of data sets. This means that you cannot compare directly the performance of the models. You have to rerun the experiments, and by rerunning the experiment, sometimes something can change. Something can be different in the configuration. Sometimes even changing the computer on which you are running the experiments can affect the final performance.
So with all those data sets to choose from, if I was developing a new method, I would want to try it on all of them or as many as I could. But I get the sense they're not all a clean, ready to go data set. I've got to do some pre processing first. What does that typically consist of?
In recommended systems, usually you don't use the dataset as it is because recommendation is not a standard machine learning task. These data that are very, very sparse. For each user, you have just a bunch of interactions. It can be like in the order of 10, 12, 100. It's very difficult to have more than that. With just that limited number of interactions, you need to predict which kind of items the user will like by facing a catalog that can be huge, can be very, very, very big, very, very large. So, for example, you can have like 20,000 of items. But these kind of numbers are the numbers that we use in research. In real life, think about Amazon, for example. I don't know how many products they have, but they are for sure in the range of billions of items. So just by looking at a very small set of interactions. You have to predict what the user will like by facing a very large number of items. And so for this reason, you need sometimes to do pre-processing strategies like, for example, retaining users that have at least a specific number of interactions, or discarding items that are very rare, enjoyed by a very limited number of users, because sometimes they are like noise in your dataset, so you want to remove them. But also there are filterings and rating strategies that are kind of a methodological approach for the evaluation of your model. For example, you can do a temporal splitting or temporal filtering of your dataset. So you want to filter out all the interactions that are before a specific timestamp or after another one, in order to retain the consequentiality of the events. So, for example, if I do a temporal splitting, what I expect from my data set is that in the training set, I have events that comes before a specific timestamp, and in the validation set and in the test set, I have items that comes after the timestamps. These kind of filterings and splitting are a way to reflect real life behaviors, real life user engagements with the platform, that still we cannot totally replicate, because of course it's not a real online evaluation, it's an offline evaluation, so it's a simulation. And yeah, that's it. Yeah, basically this is what you can find in when you have to deal with pre-processing recommendation data.
Well, could you introduce DataRec and how this open source Python library might help me balance all those intricate needs and build something a little bit more reproducible?
DataRec, as you said, is a Python library. So the idea is to make something that is plug and play in your scripts. Basically, with DataRec, to have a library that allows you to retrieve the correct version of the dataset and apply all the filterings and splitting that you need to run your experiments. DataRec derives from my experience, honestly, from all the problems that I faced when dealing with recommendation datasets for offline evaluation. It born like naturally, I collected my own scripts and my own Python code to manipulate dataset. Then study by study, paper by paper, this kind of code repository came more and more complete, with more modular and so on. And so at some point, my co-authors and I said, okay, why do not share this with other researchers? We started by analyzing the literature and see which are the most used data sets. Okay, so let's focus on them, because if you want to consider all of them, you have to consider hundreds of data sets. So it makes everything more sparse, more harder to deal with it. And then we moved on the filtering strategies. Let's focus on the most used ones. And so also for the splitting strategies and so on. And then once we framed our library based on these studies, we started implementing all of them, just make this library easy to use. We are still working on it, of course, because when you have to manage a Python library, you have to constantly update it, check for bugs, but also we are continuing by integrating useful data sets, useful filterings, and so on. Let's try to mitigate this scenario in the recommender system research, where we have so many data sets, but no one really knows every time where they should retrieve them, download them, how they should process them, and so on. Let's try to make at least this part standard. Even if, of course, people will propose new strategies, new way to deal with it, and that's totally okay. But still, let's everyone agree on how we should download and link to these data sets. So what we did basically is like to reconstruct the history of each dataset, find the original source, and make the library point only to that source. So when you use DataRec, you can automatically download the dataset. You don't have to do anything. You don't have to copy and paste from any link. You don't have to download the dataset from whatever Google Drive folder online. You have just to run the code then downloads the dataset. There is a checksum check. So that when the data is downloaded, that DataRec checks that the checksum is the same, that the library knows to be sure that modifications didn't happen. For example, it can be that the authors can of the datasets that publish the dataset can update the dataset, and then at that point you don't know, because maybe they published it at the same link. So from the same link, you'd think that you are downloading the same dataset, but it's not, because the authors updated that dataset, and so on. So this is the idea and the motivation that drove us to develop DataRec.
So it sounds like if a researcher wanted to use it, they could get a big head start, save a lot of time, get a more standardized version of the data set, pre-cleaned and all that. What is their deliverable, though, once they use it? For example, do they get a CSV, or how do they get the data?
So they come as they are from the original source. So for example, if the dataset is stored as a JSON dataset, it is downloaded as it is on your machine, but then DataRec creates a data structure on that. Even if you are dealing with different datasets that are stored in different ways, so you can have TSV, CSV, you can have JSON datasets, and so on, then DataRec provides you what we call readers for these different datasets, and you have already prepared readers and classes for well-known datasets. And then when you use the DataRec library, you see only a DataRec object, which is the same for all the datasets that are already implemented in our library. So you can reuse the same pipelines, the same splitting, the same filterings on different datasets without changing your code. You have just to change the object that you are using. So DataRec does this under the hood. But before doing this, DataRec checks that everything is okay, that the file is that. And so basically, when we add new datasets on DataRec, what we do is to identify the original source, compute the checksum, and then find the right way to transport this raw file in a DataRec object so that you can use all the DataRec utilities.
Delete Me makes it easy, quick, and safe to remove your personal data online at a time when surveillance and data breaches are common enough to make everyone vulnerable. Delete Me knows your privacy is worth protecting. Sign up and provide Delete Me with exactly what information you want deleted, and their experts take it from there. Delete Me sends you regular personalized privacy reports showing what info they found, where they found it, and what they removed. I keep hearing about data breaches in the news. In a recent Coinbase data breach, a hacker obtained names, addresses, phone numbers, and the last 4 digits of users' social security numbers, plus masked bank account numbers. Data brokers can vacuum up a lot of data, creating a searchable profile about you, and they can sell it to whoever they want. Thankfully, if your data is exposed in a breach, Delete Me can help remove it from the data broker sites. Take control of your data and keep your private life private by signing up for Delete Me. Now at a special discount for our listeners. Get 20% off your Delete Me plan when you go to joindeleteme.com/data and use the promo code DATA at checkout. The only way you get the 20% off is to go to joindeleteme.com/data. Enter code DATA at checkout. That's joindeleteme.com/data, code DATA. Thanks to this week's sponsor, Zapier. You know, these days it feels like everyone is talking about AI. Not just me. But if there's one thing you've learned from this show, it's that talking about a new technology isn't the same as implementing it. Zapier is where tech innovators break the hype cycle and put AI to work, for real. I've been using Zapier for at least a decade, building little automation workflows, and honestly, they've become even more essential in the AI era. On the podcast side, we built a bunch of publishing workflows. Audio files need to be moved around the cloud, things need to be organized. And on the business side, we've built Zapier automations around scheduling, new lead gen, inbound, you name it. The productivity gain has been tremendous. But it's more than that. It's about unlocking new opportunities I wouldn't have time for otherwise. What I love about Zapier is that it's for everyone. Tech expert or not. Yeah, I could probably code it myself, but it's just faster to do it in Zapier. You can connect top AI models like ChatGPT and Claude to the tools your team already uses, so you can add AI exactly where you need it. Whether that's AI-powered workflows, an autonomous agent, customer service chatbot, or something else entirely. You can orchestrate it with Zapier. No IT bottlenecks, no complexity, no AI hype, just results. Teams have already automated over 300 million AI tasks using Zapier. Are you ready to join them? Get started for free by visiting zapier.com/dataskeptic. That's zapier.com/dataskeptic. So what does it take for a researcher to get started? I guess it's pip install DataRec, maybe a step 1. What's step 2 through, 4, 5, or 6 perhaps?
Yeah, pip install DataRec. It's my objective because still we are doing some smaller modifications to the library. And before publishing it on the package manager of Python, we want to, be sure that everything is there and works properly. In the next future, that's the way. DataRec, it's a library. We want them to be lightweight so that you can use DataRec in your own code. We wanted to provide a library for recommendation datasets. And this comes also from the actual scenario in the recommendation research, where we have a lot of so-called reproducibility frameworks. So in recommended system research, we have frameworks, so which are like pre-constructed pipelines where you can inject your own code. So it's a different kind of approach. So they don't give you utilities to integrate them in your code. They give you an entire pipeline where you can inject your dataset or your new model and so on. So I'm not saying that that's not correct. That's a strategy, but with DataRec, we wanted to do something different. We wanted to implement a library. Okay, so something that you're not forced to stick on it. You can use it, then you can also discard it if you don't want to use it anymore. But that things does not change your pipeline, because also researchers sometimes want to implement very short snippets very fast, because just sometimes you have an idea but you're not sure that that will work, so you want to make some very fast test based on that idea and see if it's reasonable or not. And doing this on a pre-constructed framework with specific rules, specific modules, and so on, makes this approach harder. So sometimes, even if you want to test a very small modification, you need lot of time to do that on these frameworks, which are good for doing a lot of experiments and reproducibility studies and so on. But for plug and play code, for snippets and so on, I think that a library it's a better alternative.
Well, that checksum you were mentioning, I could see a scenario in which researchers who make use of the library might want to publish that checksum to say, hey, this is, like the fingerprint of my data set. Do you have any advice or a vision for how researchers that use the library might, publish something like that or something similar?
Yeah, we thought about that. I honestly, I don't know if it's already published in this version of DataRec, but we already have that. What happens in DataRec? Every single modification, every single filtering and splitting that you can do on your dataset is traced when you use the DataRec object. And at the end of this process, or whenever you want in this sequence of transformations of your dataset, you can export a YAML configuration file that can be then input to DataRec in order to redo the same processes. So to replicate exactly the same processes and obtain the same data set, of course. So this is how DataRec works. And we do that with checksums. That's the way that you can do that. But my advice for researchers and enthusiastic on recommended systems that want to do this is, even if you're not using DataRec, is don't do this at every single transformation of your dataset, because computer can checksum sometimes can be very expensive in terms of the time needed to compute it. So just do this at the very beginning, at the very end of all the stuff that you do on your data. If all the steps that you do are correct, so you fix the seed, you check that everything is replicable, then you will always obtain the same results starting from the same data set. So that's basically my advice. And even if sometimes this can be something that could be not so important, who cares if there is a little modification in this data set? Maybe the results will be the same. This is not true. Um, let's say unfortunately, because we have to be very, very aware of this problem. And the community honestly is, because in recommender systems, and in particular in the Rexis conference, we have a specific track that is devoted to the reproducibility studies, which means that in this research track, authors publish papers about strategies to be sure that the results are reproducible, or they compare previous results published in previous papers, and so on. So the community is aware about the importance of reproducibility. And yeah, I think that with DataRec, we are just trying to make this even stronger.
I know in the psychology world, they have something known as the reproducibility crisis. Would you say it's at the point where it's a crisis, or what's the right adjective for the state of maturity and reproducibility for recommender systems?
I don't want to say that it's a crisis, because on the long term, I think that good approaches will always come up, will always be more used than other approaches that maybe are not so good because they were affected by some modifications in the dataset. However, if we don't do research properly, if we don't take all the steps that are needed to be sure that our experiments are reproducible, then we are just slowing down the research. Because another researcher from another part of the world at that point will need to reproduce all the experiments. Maybe it will happen that person will face differences in the numbers published in the papers and what that person obtains by replicating that experiment. This means that that person then has to go inside your source code, understand what's happening, why the numbers are not the same. And this just slows down the research process. Let's think about LLMs, for example. They have public benchmarks. You have websites with a lot of numbers, but this makes easier for when a new model is published. It makes easier to understand if it's better or not than the previous ones. Of course, benchmarks cannot tell everything about your model, but are a good proxy feature for understanding if your approach is good or not. So I don't want to say that we have a proper crisis in recommended systems, but it's like we are damaging ourselves if we don't do research properly.
And where is DataRec at on the adoption curve?
Oh yeah, it's honestly it's a very beginning. We published DataRec in July.
Quite new.
Yeah, it's a newborn. At Rexis 2025, we will present a tutorial on DataRec. So we will start spreading the news with our colleagues, with other researchers. And yeah, so DataRec is in the early days of its life. And of course, we wish that it would be more and more used and adopted. But honestly, I wish that it would be useful for someone out there, making everything faster and easier, even for early researchers. I remember my first days as a PhD student, and I faced so many data sets, I didn't know where to start with them. And so I wish that in the next future, new researchers should not just think about that. They can just focus on things that are more interesting and more impactful, like proposing new strategies, proposing new models, finding new holes in existing approaches, and so on.
Well, what is the future of the project?
In this stage, DataRec provides to users functions and methods to transform your DataRec, export it, and make it easy to be used in existing frameworks. Because still, these frameworks that are out there are still used by researchers. So instead of proposing something that is like an antagonist of these frameworks, we want to publish something that could be, let's say, collaborator of this framework. So far, DataRec allows you to export the dataset and then to be used in these frameworks. What we want to do, for example, we were starting to do this with the CORNAC framework because the authors of this framework contacted us to do this. We want to publish versions of DataRec that are already included in these frameworks so that all the frameworks should not focus on the first part of the pipeline, which is the data management. DataRec can do that. And then the frameworks can focus on the models and on the evaluation of the results, which are the two components of the recommendation pipeline that are also very hard to set up, to be sure that they are reproducible, that they are shareable between different frameworks and so on. So the idea in the next future is to make DataRec already implemented in existing frameworks. And for sure, we will do this with a couple of frameworks. We will see if it will happen with other ones.
And if listeners want to get their hands dirty, where should they go to get involved and get started with the library?
We release a couple of usages examples. So I think that if you want to understand how to use that, take a look at that. We are going to publish in the next days our repository documentation, which I think it's something that is needed. We couldn't do that before, so we are going to publish it in the next days, I think, before Rexis, because we want to be that online before Rexis, where we will have the tutorial on DataRec. Yeah, so if you want to use that, take a look at the examples and the documentation. We try to make it as easy to use as possible. Of course, we will continue to improve it, to upgrade it. But yeah, everything it's out there. And if still you are not able to use it, contact us. We will for sure reach out to you.
And is there anywhere listeners can follow you online?
Yeah, you can find me on Twitter. You can search for Alberto Mancino. I have a personal webpage. So if you search Alberto Mancino on Google, you can find that. So yeah, I'm pretty everywhere online. So it's easy to find me.
Alberto, thank you so much for taking the time to come on and share your work.
Thank you, Kyle. It was very, very fun, interesting, and thank you again for inviting me.